Hi, this is a little video about how images are drawn in R. And there was a discussion of a few of us. I won't name people because I'm going to put this on YouTube. So the other day there was a discussion of some of us, and it seemed as though OCE was doing something odd with making an image. And then we realized that it was actually R that was doing it. I thought that R was doing. I didn't like what R was doing, but and having thought about it, I now like what I was doing. And maybe in a nutshell, before I get to this test case, which I'm about to show you, I'll tell you what the case was. So we had an instrument that sampled rapidly, quite a lot of measurements rapidly, and then kind of a long delay, and then another sequence of a lot of measurements. So just for a number, this is not what it was, but I'll say that for the first minute of every hour, we sampled once a second. So we get 60 numbers and then wait for the rest of the hour, and then 60 numbers, etc. And what we found was if you zoom in on this, that it's like there were two colored boxes within that 59-minute interval, the wait between the 1 minute bursts. So there were two boxes on that image, and I'm not going to sort of bother making up data to show you that. Instead, I'm going to tell you why I think that's being done. And I'll do it by showing you some sample fake data here. So the window where you see the mouse going up and down, that's an editor window in I'm editing R, and in the lower part of that window is output. I've actually already done this, but I'm going to walk you through it. So what I'm doing is, okay, you can see the lower window is changing. I'm running the lines. That's what it is. So I ran the first two lines. So I made X be, this is going to be the coordinates, and it was 10 and 20, and I made Y be 1 and 2. And in that line, I just made a matrix. You can see the matrix. That's the matrix that I just made there. Okay, it's a video. You can stop it. And if you want to see how you make a matrix, just do that. And a window will pop up in however you run R, a window will pop up. So yeah, stop this at any time you want. Okay, so in this line 4, what I'm doing is I'm saying I want to have 2 plot panels. The others are just setting margins because I like to have tight margins so I can see the data and not the margins. Okay, that's the first thing. I'm going to contour that. And this is what we get. So a contour by default, well, it's like a plot. And many plots in R by default, what they do is they take, I think the number is 4%. So they find the range here of the X data, which is whatever it is. And you find 4%, and I just don't remember if you tack on 4% on the left and the right, or if it's 2%, or I don't know what the numbers are. It does the same thing in the Y, and that's why the contours don't go straight to the edges. That's actually fairly convenient, but images will go straight to the edges, I think. Anyways, we're going to see what happens with images in a minute. All right, so now I want to see where the X and Y's are. So I'm going to do an AB line V. That means I want vertical lines at the X's. Call 2 is in red, and horizontal lines at the Y values, and that will be in blue. So you can see these here. So in other words, I have 4 data points, one here, here, and here. I have at the intersections of the blue and the red. That's where the data are. Now, what has it done? It's filled them in, and this is really important. It's used information from all 4 of those data, 4 data points, 4 XY points. It's used information for each of those ones. The matrix has 4 elements. There are 4 things controlling the plot. Okay. Now the next panel is going to be, I'm just going to make an image of that. So that's the, oh, wait a second. I forgot to run that line, so. Okay, so I forgot to run the line that sets up 2 things. Okay, I'll plot an image. There's the image. And you can see that it has shown me, there are 4 colors, so it somehow showed me something 4 about the data. But look at the ranges here. This has gone from 5 and not from 10. So 10 is right here. And this guy here has gone to 20, and 20 is right here. So let me draw those vertical lines and horizontal lines again. It's the same color scheme. All right, so what's happened here is it's trying to respect the data. So the data, okay, and I'm not too good on the color names, but I'll call this a dark red. and I'll call that a dark red. Okay, so this guy here is dark red. And so the way to think of this is it's trying to tell you the information where the cursor is at the moment at this intersection point. But what it does is it finds, I'll say in the X direction here, at a given Y is what I mean, at a given Y. It finds where the data are. There's a data point here. There's a data point here. Divides that space in two and colorizes in that way. And I think this is the proper thing to do. And this explains why we had, like, imagine now that this is this 59-minute gap that I was talking about here. That's trying to show you information at the end of minute 1, and then the end of minute 59, or I guess that's the right way of saying that, yeah. Or the beginning of minute, I don't know if I call the minute starting at 0 or 1. That's my question, but anyways, sorry about that. If I knew how to edit stuff out, I'd edit the last 30 seconds, but I don't know how to do that. What I'm trying to say is, I think it's doing what I think is the best thing. And so the effect of this will be, if you have a long gap in your data, you'll see patches, these color patches, you'll see 2 color patches between each. In fact, if you zoom in on anything, you'll always see 2 color patches. So, you know, and I guess I could replot this, this is going from, maybe I'll do that. I'm going to run this one again. So down here, you can see the result of that. So I'm going to say USR is, now I've captured that, and I'm going to say xlim is USR at 1 to 2, ylim is USR at 3 to 4. I'm going to run the whole shebang, as they say. So what I've just done is I've made them now to have the same, these 2 graphs, I've made them to have the same X and Y extent. And again, I've drawn the red lines on both. A little bit hard to see here, but your eyes are probably better than mine anyways. I'm just guessing half the stuff I talk about. Yeah, so that's the thing. So what it's doing is, the way to think of this is that wherever you have a data point makes a pixel. Therefore, it must color this in that red color. It must color this in that, whatever we call that color. That's what it has to do to represent the data in the same way that contours are representing the data. But then the question is, and I'll tell you, my fault was I was thinking that the color of a pixel indicated the value to the left. That's a crazy thing to think about. If it indicated the value to the left and we extended it all the way to the next data point, then we would not be showing you these data points on this side. I'll say that again. What I was thinking yesterday, this is probably only valid for people who were in the meeting yesterday. If we extended this yellow color all the way to here, which is what I was thinking we should do, in other words, to have constant color between any 2 data points. If we did that, we would discard the data on the right-hand side always, and we would always discard the data on the top. R doesn't want to do that, in the same way that when you plot with points or with lines or with contours, it doesn't discard data. It tries to show you all the data. I think that's about what I wanted to say. I'm not sure really if this makes any sense to anybody. It might make sense to the other people who were in the meeting with me yesterday. Thanks for your patience in listening to me yesterday, being confused on that and thinking that there was a problem. Bottom line, there's no problem. R is doing the right thing. And it's just, yes, R is doing the right thing. That's the end of the video.